So to make sense of the gas laws, which we're about to discuss, it's really important that you can visualize how a gas behaves. What's known as ideal gas behavior and is also called kinetic theory. And as the name kinetic, meaning motion, theory implies, gases are, of course, going to involve a lot of motion of particles. Now, there are 5 postulates associated with this kinetic theory, and the first is quite simple. Gases are composed of small particles that are in constant random linear motion. Now, notice I use the word particles instead of the word molecule or atom, and that's because some gases are small molecules like carbon dioxide, 3 atoms covalently bonded together. But some gases are noble gases, which are individual atoms, and therefore you can't call them molecules. So I just replaced the term molecules and atoms with the word particles. So gases are all composed of small particles, and that's important because if the molecules of a gas or any substance get bigger and bigger, the attractions between them gets greater, and therefore they tend to stick together instead of separate from one another in the gas phase. And instead of a gas, you begin talking about a liquid or a solid. So they have to be small particles, and they are moving in a very specific way. They're moving constantly, they don't stop, and their motion is random. You have no idea what direction a particular gas particle is moving, but they do move in straight lines, linear motion. So, of course, if they're moving in linear motion, first of all, we've already learned that temperature is a measure of average kinetic energy being the energy of motion. And so the greater the kinetic energy, the greater the temperature. And the speed of the gas particles is directly related to the temperature of the gas. In other words, if you have a hot gas, the particles are whizzing around much faster than if you have a cold gas. So speed is a measure of temperature and vice versa when it comes to gases in particular. Now, the third postulate is if these particles are moving in straight lines, eventually they hit something, either one another or the container walls, the sides of whatever the gas is contained within. And so these collisions are occurring constantly. And the interesting thing about collisions in terms of the kinetic theory is that they're completely elastic. Now, a physicist calls an elastic collision any collision where there is no loss of kinetic energy. In other words, when the particles collide with each other or with their container wall, they maintain the same energy of motion after the collision as they had before the collision. And since we measure kinetic energy via temperature, it means that all these collisions that are going on constantly in a gas do not affect the temperature of the gas at all. It will retain the same temperature because the collisions are completely elastic. Fourth, and kind of interesting is, and it implies something, the space within the gas's container that's physically actually occupied by bits of matter, mass, the atoms, the molecules themselves, is negligible compared to the size of the container. In other words, these little bits of matter that make up the gas are spread widely apart, and most of the container is empty space with a few particles here and there. And this implies that gases have very low densities. In a 1 liter container containing some gas, there may be only a few grams of actual matter in there. And so the particles are widely spread apart, and therefore they have a low density. Typically gases do. You can compress gases. That means push the particles closer together, take them out of a larger container and put them in a smaller container, and they still fit. You can make the container yet smaller still, and they still fit. And eventually, if you got a small enough container for your sample of gas, the gas would take up all of the container, and it would no longer be a gas then. It would be a liquid or a solid. It would occupy the entire space of its container. And so yes, For it to be a gas, ideally, the particles themselves take up a negligible amount of the space of the container they're in. And then lastly, for it to be a gas, ideally, there cannot be any significant attractions between the particles. The attractions must be negligible. And this is for a very good reason as well. If there are strong attractions between gas molecules, when they come close to one another or collide, they might stick together. And if the particles all started sticking together, once again, you would not have a gas at all. You would have a liquid or a solid. So, of course, 5 things have to be true for you to have an ideal situation for your gas and to follow kinetic theory. And that is small particles in constant random linear motion, and that the motion itself, the speed of those particles, is a function of temperature, and that the collisions that are constantly occurring between particles and the container walls are completely elastic, has no effect on kinetic energy, and the particles themselves occupy very little of their container space, and the attractions between those particles are negligible. And if you can keep this image and description of a gas in your mind as you're studying gas laws, you will find that most of the laws are common sense, and you will not have a difficult time remembering them.